Good morning, everyone. Can you hear me clearly? This is Sandeep Giri here. I'll be the instructor for today's class on Big Data and Hadoop. Use the questions window to communicate with me. Everybody is muted. Hi, Harish. Hi, Asgar. Hello, Apurv. So, before the session starts, it will be great if you introduce yourself. Hi, please feel free to introduce yourself. Right. So, Harish, Harish's point is that I'm seeing you are muted by organizer. So everybody is muted because there are going to be many people in the session. So the way you have to introduce yourself is by typing in the questions window and tell about yourself. Hi Manish. Manish is from Minneapolis and he's a software developer target cop. Oh great. Hi Asgar. Asgar is from Bangalore and is a co-founder of a company, web design company called Hackswale. Great, great. Hi Casey Reddy. Hi Sashikant. Sashikant is from Mexico. He works with Oracle BI and Spotfire administrator for TCS, serving a big healthcare customer. Great, great. Hi Apurv. Apurv is a software developer at groups.common floor. Awesome. Okay. He is originally from Lucknow and currently working in Bangalore. So today's class is the first class and it's an introductory class. In this class, there are more people, and in our typical class, there are going to be 23 people at max. Okay. And also in our class session 2 onwards, from tomorrow onwards, we'll be using something called go to meeting, where you can see each other's question, as well as you can chat using the chat window. All right. And there will be only 23 people from tomorrow onwards. So please feel free to introduce yourself as you join using the questions window. Everybody is muted by default. All right. So please feel free to introduce yourself. Hi Karthikeyan. Karthikeyan is working as a software developer at Common Floor. Great to know you, Karthikeyan. Hi Satya. Satya is working in telecom billing domain for last 10 years and currently with IBM. Great. Okay. Okay. Hi Vishnu. Vishnu is from Emphasis. So Vishnu, this session is going to be exactly what you have attended at Emphasis. Okay. But it's good to get refreshed. Hi Abhishek. Abhishek is working in BFS domain, banking and finance, financial services domain for last 10 plus years. Great. So as you are joining, please feel free to. Feel free to introduce yourself. Good morning, everyone. So let's start the session. I'm Sandeep Giri. I'll be taking you through the Big Data and Hadoop session. It's an introductory session. We'll cover about in general what is big data, why do we need it, and how to identify. And then we'll talking about what are the various solutions available for big data handling and how do Hadoop solves the problem. Okay. So we'll talking specifically about HDFS in the Hadoop. All right. Use the questions window to communicate with me because everybody is muted. There are around 30 participants as of now, but I expect that in next 5 minutes it is going to grow more. So that is the reason why everybody is muted to avoid the collision of the voice. So please feel free to introduce yourself using the questions window if you have not introduced yourself already. Okay. These sessions are recorded and all of these slides will be shared with you, so you do not have to worry about taking a screenshot or wasting your time in noting down a lot of stuff. But it's a good practice to note down, jot down things so that you can remember. All right. Good morning, Sanjay. It'll be great if you can introduce yourself. All right. And the first session is generally for a larger audience, and therefore we use GoTo webinar instead of GoToMeeting. And from session 2 onwards, we'll be using GoToMeeting, where you can see the list of participants as well as you can communicate with them use to with all, and you can see the question asked by all. Here you can't see the question asked by others, so I will be reading out the questions for you. Okay, and will before answering. Hi Raghu. Raghu is a senior DBA, Oracle DBA specifically. Great. And hi Giridhar. Giridhar is a C++ Windows professional with more than 12 years of experience. Please let me know how big data certification can help me grow. It will help you grow, and we can have a discussion separately about this. But that definitely people of your background will definitely get benefited from big data and Hadoop. Okay. Hi Gridhar. Gridhar is working in HP in telecom domain in big data analytics product development. Great to know you, Gridhar, and welcome to the session. Okay, then I'm starting now. And let me do the final introduction also. Hi Sanjay. Sanjay is working as a ETL domain. He's an ETL developer with a working knowledge of tools like Talend, MSBI, Teradata. Excellent, excellent. All right. So I'm Sandeep Giri. I'll be the instructor for this class. And let me tell you a little bit about No Big Data before we proceed further. No Big Data is a big data training organization where The primary focus is explaining the complex concepts and being able to answer your question. To facilitate the learning, we have a learning management system to which we give you the access for lifelong. Okay. So those of you who have given only their organizational ID, please share your please share your personal IDs because we provide you the access to the content for lifelong. Okay. All right. So please share your personal IDs because we provide you the lifetime access to the content. And the recordings of all the classes, including this one, will be available in Learning Management System as well. And the most important thing which differentiates us from everyone else in this industry is our cloud labs, where we try to provide you a cluster of multiple computers pre-installed with everything you need to learn about big data. So when you are learning with about any component, you can explore how does it work, and all of our trainings are around the technologies which belong to the big data domain, and therefore all of these big data components require multiple computers to run on, and and therefore we had set up the cloud lab so that you can really feel how does a component behave when there are multiple computers. All right. So that makes the bigger reason why we need cloud labs as opposed to the virtual machine which everybody else provides, because having multiple computer setup gives you really good exposure to all these components. All right. We provide you 24 by 7 email support. If you have any questions, just drop us an email. You'll get a response in a very reasonable time. Also, other than one project which is mandatory for all, we provide you a real life project. Real life means real life as in it will be for our actual customers, actual knowledge partners. And but real life project is provided only to those who really perform well in our rest of the course. Okay. So we provide you quizzes and certifications so that you can you know learn and make your knowledge stable. And we provide you these sessions are going to be a total of 11 sessions. Each class is going to be 3 hours class with a break at in the middle of the session. And from tomorrow there will be two breaks, as some of us have just advised me to have two breaks. Okay. The other thing is that we can help you in improving your profile by giving you a social and professional networks visibility. All right. So let me just. Okay, there are a few more people who have just joined. Hi Bharat. Bharat is new to Big Data and Hadoop and he works in storage division of HP. Great. All right. All right. So Agreed, drop me an email rather than telling your email ID here because right now I won't be able to take a note of it. All right, because and hi Noble. Noble is a ETL developer. Hi Shri Kumar, currently working as ETL data warehousing tester with 9 years of experience. Yes. Okay, great. All right, there is no criteria as such to attend for certification. His question is that is there a criteria for attending the certification? There is no criteria for attending the certification as long as you are finishing our course. Good. And so in today's session, out of 11 sessions, today we are going to discuss about understanding big data and Hadoop. Okay, I missed my own introduction. All right. So myself, Sandeep Giri, I did my graduation from IIT Roorkee in 2002, and from for afterwards I worked for a company called DE Shaw. So we were building the big data systems when people did not call them big data systems. Okay. So for example, we were handling a 10,000 node cluster at DE Shaw, where we were having we were building various kinds of platforms for our research scientists as well as various kinds of end users so that they can run high-end computing on these platforms. All right. So Disha was far before Google's and Amazon's. We had the bigger cluster than anybody else. Okay. Now afterwards, I founded a company called Tbits Global. Tbits Global is a company which provides a software, a document management software for large organizations to do their to do the document management, specifically to the people who are from the specifically to the companies such as uh, construction and EPC, such as L&T Power, Tata Projects. So it's a product company. Now afterwards, I joined a company called InMobi. There, I built a recommender after churning 200 terabytes of data. Okay, and at InMobi, I did couple of more systems which were really high throughput and high performance. At Amazon, again, I was working on a similar high throughput systems, basically the the solutions which lie in the big data domain, such as using a real time system a system which runs on hundreds of computers parallelly to do the image processing for their detail page. Okay. And in the beginning of this year, I started knowbigdata.com. Okay. So we have been fairly successful in this domain, and I see a lot of the quality trainings which we are bringing in puts us, I mean, makes us far different and improves the learning to let various people. All right. So without further delay, let's jump in. Okay. So yeah, Yalahanka's question is, I have heard Java is mandatory for MapReduce. No, Java is not mandatory, but a bit of programming knowledge would really help you understand MapReduce. Okay, so MapReduce is a concept, and for that you can use any of the programming language. And in our past, even those people who have not coded for quite some time, they were able to write MapReduce very easily. Okay. Bharat, my email address is sandeep at nobigdata. And don't worry about it. We will let you know anyway. Okay. All right. So far, what do you understand by big data? When people say big data, what does it mean to you as of today? So Yalahanka's next question is, as Oracle DBA, how is the transition? Transition is actually smooth. It's not that difficult. Okay. Only during the first two sessions, you might feel a little uncomfortable because we'll focus more on the map reduce. All right. But that will, but trust me, if you, work with in the first two sessions, you will get really, really comfortable with all of the technology stack. And do I need to be big data developer as admin or as admin? So big data developer is the right place for an DBA. Okay. All right. So big data is handling large amounts of data as per Asgar, and okay, okay. So Parvela's question is, will basics of MongoDB be covered in upcoming sessions? Yes, not today, but in separate sessions. Okay. All right. So Nitin, can I answer your question a little later? Just remind me towards the end of the today's session, and then we can discuss it. All right. Anyway, let me try to answer now. What are the prerequisites for learning big data if you're coming from C++ background? Have people been really able to switch to big data domain after getting big data certifications? So, big data is a fairly new domain. People have not been in big data for years. Okay, so of course, when you see nowadays that there are people who are into big data domain, obviously they have switched from some domain or the other. Okay, so that proves that people are able to successfully switch the domains, right? And the prerequisites wise, you should know about databases. You should know about a little bit about any coding, any programming language, whether it's Python, even if it's Shell, it's okay. Okay. Or even if you have read C++ 10 years ago, then also it's fine. But you should have some sort of at least some bent where you had been exposed to the programming language. Okay. I'm not i'm not saying that you should be hands on, but you should be acquainted with the programming language. And third thing is, you should be comfortable working with the command line, because most of these tools are command lines, not all of them have UI. Therefore, you should be comfortable working with either Linux, specifically if you are okay with basics of command of Unix, and it's really good. If not, just go through the first tutorial of Linux, any first tutorial of Linux, and you will be comfortable. All right. So that is prerequisites. Okay. All right. All right. Ashirwad, that question about the difference between big data and other kind of relational database like Oracle will get clear to you very quickly. So big data is, as per Yatish, big data is problem to deal with large amount of data to overcome the challenge of dealing with the huge data. It's mainly deal with velocity. Good, good, excellent answer. Abhishek, what is a good place to start learn big data? Today's session. Okay. Again, Abhishek Pandey is data which is very big in size, more than excellent, excellent answer. Sanjay is saying new technologies to handle all the data which traditional RDMS has. Excellent, excellent. Volume of data, variety, velocity equals big data. Good. The way file structures evolve into databases further evolved into big data. Okay, okay, that's a good point, and that's a new way to look at it. That was Shravan. Gridhar says it's a jungle of data, including structured, semi-structured, and unstructured. All right. Yes, today's session is first session amongst the 11 sessions. Yes. So Noble's question is, do we get working environment where we can? Yes, that is what is Cloud Labs about. Okay. So those who sign up for the full session, they will get access to the Cloud Labs from, and they can practice as we go along. Okay. So big data is large data sets of data which can be analyzed to drive new patterns and trends. Good. That was Sri Satya. Structured and unstructured data is big data as per Yalanka. Good. So, yes, we'll go at a little faster pace, Manish. Don't worry. All right. Great. So, when we talk about big data, the most important part is that it's the third point in this slide, which is distributed architecture needed. Okay. That's the most important part when we talk about big data. Big data is simply data of very huge size that you cannot process using the usual tools. Usual tools as in existing file systems, existing relational databases, or existing ETL tools. Okay. So when you are in that kind of scenarios where you are not able to handle the data, or you are not able to solve your problem using a single computer, and using the existing solutions, then you say that, hey, I'm dealing with big data. And and specifically when your distributed architecture, when I say distributed architecture, it means that being able to run your program or run your code on multiple computers, utilizing all of them simultaneously to solve your problem, is distributed architecture. Okay. So when the data is of huge size that you cannot handle with your usual tools, and you require a distributed architecture, then we call it big data. And this data can be structured or unstructured. Structured means that we know what fields our input data contains. We know that this is first field, this is second field, this is third field, and we know the data types of each of these fields. For example, a database table. A database table is completely structured. We know which field is of what type, and from where one field ends until from where the second field starts, right? So an unstructured data is something like a plain text file where we don't know how is our data organized. To convert our unstructured data into a structured, we would require parsing the data. We would require a code which will understand unstructured data into structured data. And lot of ETL work is involved into conversion of either unstructured to structured, or from one structure to another structure. All right. And there's something called semi-structured data, such as CSV file, where we know CSV is comma separated, where we know that our one field starts here, second field, we know the differentiation between field 1 and field 2 and field 3 and so on, but we do not know their data type. That is considered as semi-structured. Okay. Now, that is what we call as big data. Right? So this is the definition you need to stick to, specifically third point. So whenever you try to do processing of any sort of data and you require that, hey, I need a distributed architecture, then we say that, hey, if you're dealing with big data. All right. So all the tools that we will be talking about, they all run in a distributed fashion. They all run on multitude of computers simultaneously to solve your problem. All right. All these 11 sessions cover around 11 products, 11 tools. They all are on distributed architecture. All right. Now, what is big data in terms of the standard definition? So this is the definition given by IBM, and they have been adding one V every year. They started with three V's, and probably now they have added one more V. All right. And yeah. So as per IBM, the definition of big data as they have given is by virtue of any of these four components, by virtue of any of these four V's, if you end up using a distributed architecture, or if you end up in a situation where your existing tools cannot solve the problem, then you say that, hey, I'm handling the big data. So if the volume is a problem, meaning imagine handling a very huge data, and to handle such kind of huge data, you say that you cannot do this kind of you can't even store this kind of data on a single machine no matter what I do. Then we say that because by virtue of the volume, it's a big data. All right. Then the second part, which is very, very important, which we all miss out, that a data can be considered as big data due to its velocity also. Okay. What does it mean by velocity? Volume is straightforward. The storage. Okay. The storage. The velocity is little tricky part. So imagine this. You have built a beautiful website counter, right? Which basically helps you measure the traffic on your website or multiple websites. So at the end of it your website counter is just increasing a single number. But imagine this. If to increase this single number, you are making call to a database, one read call and one write call. And as the request on your website grow from from say few hundreds a day to few millions in an hour. Okay, say you take your website and post on a forum like Slashdot. Now you will get few hundred thousands requests on your website in couple of hours, in every minute or in every 5 minutes. Now this code which just counts will get so many requests, although at the end of the whole day it will just increase a integer or a long, which means there is no significant data storage. It has increased, the website counter has only changed a variable, but there are so many requests that your single computer cannot handle it. Okay, so in those situations there are so many requests that need to be handled by multiple computers. Then we say that the velocity is too high, and because of velocity our problem is a big data problem because we require a distributed architecture. Third one is variety. There could be a third case where volume or velocity is not a problem. Volume is low and there is no velocity, and still you might need to use a big data solution, or you might need to use a distributed architecture or multiple computers to solve your problems. Okay, such as take a case of finding path in a map. Okay, so if you take a graph of say Karnataka and say it's around 200 GB. Okay, now although the volume is not too big, and the velocity is also not there. But when you have to find a path in this kind of map, it might take a lot of time. All right. And in this scenario, you might realize that if you had, say, 100 computers, you will be able to answer in 5 seconds. All right. So that's what is velocity. And fourth one is veracity. Veracity is something I do. I mean, every year they keep on adding one more V, and they have just added one more V. Okay, let me explain it. But so so veracity is a problem caused by, I mean, the when your data becomes unhandleable using one computer due to duplicacy, due to confusion whether this data is to be deleted or to be kept, and you're not so sure whether this data is of any use. Till the point you figure out that the data is of any use, you need to keep it. Also, you need to handle it. In those circumstances, you call your data to have the veracity. Okay. So, say for example, you have three data sets of the temperature readings across the globe. One by GPS location, other by pin code, and third one by city. Now, all these three datas are similar to each other, okay? But unless until you figure out that you can reach to one data set from another data set, you would not really know whether to keep the other data sets or you whether to delete it, okay? So in this case, in this example, you end up storing three times of data, as well as you ended up processing three times because you have to figure out which one is useful, right? So in these circumstances, we call that our data has got veracity, and by virtue of the veracity, we have ended up in the big data problem. All right. So that is veracity. Yes, Sanjay, where velocity can be compared to an audio clip, so its streaming should be faster. Yes, you are right. Like for example, doing a YouTube, a single video has got a space of 1 GB, but when hundreds and thousands of people are watching the same video simultaneously, it is going to require multiple computers instead of single. All right. Good. Cassini's question is that does elastic load balancing replaces big data if we take velocity as part of big data definition? Yes. Okay. So that's a basically elastic load balancing is exactly one of the solutions we say about big data. Can't Oracle DB solve the velocity problem? That is Satya. Not all the time. Okay. When you have millions of requests coming in, we will talk about this. You will understand that. Okay. So we'll talk about even before Oracle DB, even your usual file system will not be able to handle lots of kinds of load. All right. And for variety, you can. Annapurna is asking for another answer. So another example of variety you can think of processing a lot of images, like I was doing in case of Amazon. So in case of Amazon, what I was doing is I was doing a selection of the product image out of hundreds of images. Okay. And this selection had to be redone again and again as the data changes. As the information and confidence about various parameters on the detail page changes, we change the product image. Okay. So we had to pre-compute the product image so that when the user is requesting for a product details from amazon.com, we need to just present the whole image, whole page quickly. And for doing that, we used to keep the image pre-computed. And in the batch processing, we used to do a lot of churning of the various images simultaneously. Every 5 minutes, it would kick in, or every time a vendor changes anything, we will kick in this. And based on seller image, will replace it. Now, the problem sounds quite simple unless you realize that there are hundreds of updates coming every minute. Okay, which means your image processing has to be really faster and stable. Okay, so to do that, we distributed the processing of the images to multiple computers. Now, why did we need to distribute it? Because processing image, although the number of requests, if I talked about say 50 per second or so, if it is about normal data, it's quite handleable. But when we talk about images, you need to process this data. You need to process an image pixel by pixel to figure out how does it look, right? Therefore, therefore, because of the variety, because our data had a different kind of variety, because of the firm, the processing was difficult. And therefore, we ended up using a big data solution which runs on hundreds of computers parallelly and does the processing for us. Okay. So Sri Satya and Annapurna, was I able to explain your question, because both of you were have right. Yatish is right. When we are dealing with the social data, veracity is an issue, as you know, the authenticity of data, and are dealing with the business. You can't trust the given data and go ahead with the analytics. Instead, you would like to check the. Yeah, that's right. That's right, Yatish. Thank you for that. Right. Good. Thank you, Yatish. Yeah. So that was about the classic definition of IBM. But to be very honest and blunt, stick to the point number three. Whenever your problem requires distributed architecture, call it big data. Okay. If somebody says that I'm solving big data problems of the world using my single computer or my laptop, then he's obviously bluffing. Okay. So, and he doesn't know what he's doing. Okay. That includes the very large corporations of the world. They have started claiming their single node compute uh, softwares to be big data problems. Okay, big data solutions. So we do not agree with that. All right. So we'll just stick to the third point. All right. So just to check if you are awake or you are listening to me. So how many petabytes are there? How many bytes are there in the petabyte? Just quick answer. Let me see, and then we move on. 1024 terabytes. That is Yalhanga. Go. Sanjay is 10 to the power 15, and all right. 1024 to the power 5. Thank you, Sri Satya. That is probably the way to on this. Yes. Great. So almost every one of you is correct this time. For the first time, all of you is have given a correct answer. Great. And I don't know why everybody is so right this time. Not a single person in the batch has answered wrong. Wow. Great. This is definitely the best batch I could have. All right. Yes. So a petabyte is basically 10 to the 15 bytes. And the way you can remember is this table: kilo, mega, giga, tera, peta, exa, zeta, iota. And the each one is 1024 times the previous one. So saying a petabyte is 1024 to the power 5 is probably the easiest way to say. Okay. That's easier than counting the number of zeros. Awesome. Now, the bigger question to you. So, we gave a definition about big data, and we also gave the definition of petabyte. So, my question to you is that is 1 petabyte really a big data? And if you say no, then tell me why. Why no and why yes? Okay. So, just first yes or no, and then you can go into the details of your reasoning. Okay. A quick yes or no. Okay. Yatish says not really, depends on what you want to achieve with this data. So, Yatish, let me ask you this. What is it that you want to achieve with 1 petabyte data at least? The minimum thing you would like to do. Of course, you would like to store 1 petabyte data before you want to do anything with this, right? So, no, even if you do not want to do real time statistics, real time analytics, tell me how are you going to store 1 petabyte data on using a single node, even if it's a supercomputer? Yes, thank you, Gridhar. And awesome. So, great. So, as I told that big data is not the solution or is not the tool. Big data is big data. As simple as that. Big is an adjective and data is the noun. Okay. So let's not confuse big data with big data solutions. Okay. Big data doesn't solve anything. Big data is a problem to be solved. All right. Okay. All right. All right. So yeah. So as of now, even if you have say you have what? What's the biggest hard disk do you have generally as of today? Is I have not heard beyond 5 terabytes of hard disk. And to store one petabyte of data, how many hard disks do you need? You need close to 500 hard disks minimum. Okay. Now, how do you connect these 500 hard disks? Can you can you store it on one single system? Now, the only way you could do using traditional ones is connect these 500 hard disks in a network. Now, if you connect that, there will be problems, and those problems we'll discuss shortly. Okay. Therefore, even for the proper storage of 1 petabyte data, you would require a big data solution. You will require a distributed architecture to properly store and reliably access this data. Right. Yatis's point is there are only very few players who have 1 petabyte of data. I do not agree with this. Okay. There are only few players who have data. Yes, true. The more true is rest of the people never intended to store the bigger data. All right? Because think about this. Every class of mine ends up generating 3 GB of data. A small company like ours. And when I was talking about InMobi is a small company. and we had beyond a petabyte data, out of which 200 terabyte data I handled. Okay, so since companies are not inclined to store humongous data, therefore they some of them have, some of them choose to delete it. All right. So it's not a fictitious question. It is just, can you provide 1 petabyte storage? Is the equivalent question. If I change this question into, can you providing 1 petabyte of storage is a big data problem or not? Right? All right. So even if I change my question to, can you provide 1 petabyte data, then your point is not relevant, right? Meaning that people don't have big data, therefore we should not talk about it. Therefore, it's not a big data, right? So good. All right. Yes, Venkat, you had some question. All right. Now we have, so good. So hope we should go ahead. Uh, all right. So yes, properly providing a 1 petabyte of storage is a big data challenge, and we'll talk about in a minute. Don't worry about that. And so this is a classic graph which says that a, the digital storage and analog storage. So in 2002, the digital storage, the lower part of this graph says that the digital storage started expanding drastically. It suddenly started expanding really, really fast. And this is not a linear graph. It's exponential graph. Okay. So it shows that this graph shows that in 2002, the digital storage of the world started increasing suddenly, and by 2007 we had 280 exabyte of data in place. All right. Now, why did it happen? The answer is really, really straightforward. Answer is devices and the networks, devices and the connectivity. So while on one hand, devices kept on becoming cheaper, faster, and smaller, okay, cheaper make them available all across, faster makes them made them really able to solve the problem and made these devices really useful, and smaller made them such that a camera kind of a thing is there on your small smartphone. Okay, so more sensors, more and availability and being able to do useful stuff made it possible, that made the whole devices really, really popular and available all across. And more the devices, more the data that could be generated with these devices. All right. And on the other hand, connectivity kept on improving. As of today, people have 30 mbps connectivity, and there is a wi-fi, and there is a 3D 4G and all that sort of things. So all of connectivity from all means started expanding drastically after 2002. It was increasing earlier also, but most of the change happened during or nearby 2002. All right. And the other reason is, when these hardware constraints were being removed, parallelly people started developing really, really cool software which helped put all the hardware devices and the connectivity into a real use. And that's where the social network and the connectivity between people came in. All right. So connectivity between people, between things, or between people and things, howsoever you want to put it, as well as the devices, made it possible to expand the data, for the data expansion suddenly. All right. All right. So good. Now we talked about, you know, why there is data, what is big data, and why do we have a data issue now. Now let's talk about why exactly, and what are the hardware components that matter when we deal with deal with the data or big data or any processing. Okay. Yeah. So Ashirvad's question is, so we assume mobile revolution and social networking as invention start point need for big data concept. More than that, so social networking and all of these are just one implication. There are all other major dimensions also. The the beginning is availability of the hardware and availability of the connectivity. That is the basic reason why we have big data as of today. All right. Now, so when we talk about processing or handling the data, there are effectively four major components that really matter in processing. Although every component inside your computer does matter for processing, but these four are the main ones. When we talk about scaling up, scaling out, all of these things we'll talk about in detail. So CPU, everybody understand the CPU is that flip-flop thing which reads the data from various, whether RAM or registers or L2 cache, L1 cache, and does the processing and puts the data back into those memory. So L1 cache, L2 cache, registers, and RAM, we are all calling them RAM right now. So first is CPU, then is RAM, then third one is disk, and fourth one is network, right? So in case of network, it's network speed that matters, while in case of disk, it's size of the disk and the speed at which you matter. So the fourth one, which is network, is probably the most interesting one. We never counted network as something which plays a role while doing the computation. Okay, so when we say caching, what does it mean is we move data from the disk to the RAM. That is caching. Okay. and and when we say building a distributed file system, we basically move our stuff from one disk towards the network, right? So when we build the solutions, we will be moving stuff from one place to another, from network to the disk and disk to the RAM and back and forth. Out of all of this, earlier only the RAM used to become the constraint in the beginning. Okay. And later point of time, when you try to solve the RAM, the other components would start becoming the bottleneck. So you have these components, and at least one component will become a bottleneck when you are processing a big data. Okay. At least one component become the bottleneck. Either it's CPU, or it's RAM, or it's disk, or it's a network. Okay. So any of these four components at least will become the bottleneck. At least one of these. Like for example, when we are dealing with 1 petabyte of data, your disk size becomes the problem. And when you try to move this data to network, the network becomes the bottleneck. All right. Or think about it that you have to process a lot. You have got a lot of velocity. In those cases, your RAM and CPU becomes the bottleneck. Okay. Your lot of requests coming in from the user, The storage is not becoming the problem in those cases. Your RAM and the CPU will become the bottleneck. All right? Because every time you open a network connection, you require extra RAM for this. And more connection you open, more and more RAM gets consumed. In one of the solutions in Mobi, we ended up we ended up using enormous amount of RAM, 200 GB we ended up using. And that's when we realized that, oh, we can't really keep on increasing RAM. We'll have to make it properly distributed solution. All right? All right? So Yatis's point that is that business considered what is so-called useless data earlier. Now I started to treat them useful data, so it became significant. Yes, that's a very good point. Thank you. Yeah. All right. So at least one of these components are going to become the bottleneck. And remember that when you put one more computer to process, all these four components are getting doubled as opposed to vertically scaling up. In vertically scaling up, only one component is generally increased. Okay. Okay. So Nikhil, what was your question? Right. So before I talk about vertical or horizontal, let me give you a quick definition of vertical scaling and horizontal scaling. Vertical scaling means improving your single computer's hardware. Say changing your RAM from 1 GB to 2 GB, or changing a processor to 1 gigahertz to 2.5 gigahertz. That is vertically scaling. We are improving our hardware. And horizontal scaling is putting multiple computers parallelly to solve your problem. All right. So if you had a bullock cart, instead of removing the bull and putting an elephant in the cart, that is vertical scaling. Okay. Removing the bull and putting an elephant in the cart is called vertical scaling. While while putting two bulls in the cart is horizontal scaling. All right. So So when you horizontally scale, all of these components actually double, and that becomes really, I mean, a big relief. Okay. So we can comfortably say that if you are putting two computers parallelly of the same capacity, the capacity is your overall ability to solve the problem is not only doubled, it has increased manifold. And the manifold depends on how well how well you have structured your solution. Okay. Because when you have another computer, you got a better processor, you have got bigger wires, more, I mean, the ability to transmit data between CPU and RAM has increased, and similarly read speed and disk size both have speed increased. So when you scale up to double your capacity, meaning double your number of computers, your ability is manifolded increased instead of increased by only 2x factor. Okay. That is something you need to remember it. Okay. All right. Good. So these are the classic cases of big data customers. And the first one, I've worked upon almost all of these problems at one point of the time or another. First one is recommendation engine. In recommendation engine, why does it matter to have big data? So All right. So a recommendation engine is nothing but providing you sort of a recommendation. Like in school, we used to ask our friend, "Do you like this movie? I like this movie," and then we figure out what else do we have in common, and based on that, we used to decide whether to take the other person's movie as a recommendation or not. All right. So in the exact similar fashion, most of the recommendation systems work. They try to cluster multiple people together based on their, you know, based on the movies they have liked. So if there are 50 people who liked, I mean, 90% of the movie, who had the common movies, 90% of their movies as common, then that means they are quite similar. And we can comfortably give the recommendation of one person to another, movies of one person to another as recommendation. All right. So that's how most of the recommendation system work. And by now you must have figured out that more the number of people you have, the better recommendation you can give, right? So if there are only two people and we start saying, oh, we have got great set of matching users and this and that, then obviously your predictions are not going to be very very accurate, right? So the more number of users you have, the more number of their past history you have, the better recommendation you will get, right? Therefore a recommendation makes a classic case of big data problem, right? All right. Second point, ad targeting is not common to all. Ad targeting is very specific to few people, okay, such as Google's and other worlds. So I'll skip this part, but I'll talk about search quality. Search quality is something which is very, very important to a lot of organizations. So when we were building our product called T-Bits in from 2006 to 2011, so that time we realized after launching our product that we need to improve our search quality. Okay. People complained that we did not give the right results. Although the kind of data we were handling was close to at max 150 gigabytes, that's all, in the document management system. And we needed to provide the proper searches into the data. And how could do that? And why did it matter? So let's take a case of some 100 gigabyte of documents which people need to search, and let's say they are searching for a keyword like blue dart, right? Now blue dart could be written in hundreds of ways, right? Blue dart can be written in hundreds of the ways. So to really give the experience to the user, you need to automatically figure out in how many ways people can type blue dart, right? And then you correlate it and show the results correctly. So if people can write blue dart as continuous blue and dart, and then people can also write blue dash dart, blue space dart, and so on, right? Because people will not write something like double quotes big space double quotes blue space dart. That also people will write. Now now I mean, you cannot force that this is the only way you have to ask question. Okay, when people are using your system, they are using for the convenience. Okay, therefore, if your system is not able to provide uh, answers in really really relevant manner, then your solution is useless. Okay, so therefore you have to build maybe a big dictionary by crawling the internet or by processing the existing crawlers data or the corpus of the internet just to provide the search quality. Okay, understand what does a word means, what does blue dart means, is it is it a single word, are these two different words, and so on. Okay, so when we talk about search quality, you might, even though your actual data is smaller, but to give the recommendations, you might end up churning humongous data. All right, providing auto completion, providing suggestions, categorizing your components, categorizing your products. Similarly, if people searching something and people are searching for say shirt, right? So in case of Amazon, shirt might exist in millions of books. Search might exist in hundreds of thousands of books. But search, I mean, shirt, that keyword shirt is more relevant. If users are searching for shirt, they are they might be trying more to to buy a shirt. So instead of giving the first set of recommendation about books, Amazon gives you the recommendation about shirt in the search results at the top, right? So that is the whole game about search quality, and that requires a lot of data processing, even though your actual data might be very small. All right. Right, that's right, Yelahanga. Statistical analysis of share prices. Yep, right. Now, the the fourth point is the sentiment analysis. So, sentiment analysis means that what is the common common response of the people towards your brand, towards your campaign, and what do people think about your product or your brand name, right? So, say for example, a movie is getting released today, right? So there'll be some sentiment about the movie based on the promotion so far, right? And as soon as the movie releases and people watch that movie, the sentiment of the people will change. People will realize that the movie was useless, it was completely pointless, or people might realize that movie was far better. So there'll be a difference between what was the sentiment of the people based on the ads and the reality, right? So this understanding of people's response to your actions towards a brand or a product or any of the services you're providing. So this analysis is called sentiment analysis. And the easiest one is your easiest one is analyzing Twitter's data, because that is readily available to everyone. All right. So we will, in one of the sessions, we will talk about end to end building a recommendation. Okay. How do you build a movie recommender? And fourth one, we will talk about the sentiment analysis using Twitter data while discussing things about uh, towards the end of the session number 10. All right. So, and abuse and click fraud detection is another thing which lot of companies work upon, specifically Googles of the world, just to figure out that one person should not just click on other person's ad and make the competitor lose the money. Okay. So other use cases are telecommunications. I mean, there are millions of use cases. These are just commonly understood use cases. Okay. In telecommunication, it's being big data, the kind of data they're churning, it requires a big data kind of processing. All right. Similar is the case of in the government. For example, for Aadhaar, they actually used big data, I mean Hadoop, for solving their problem. And most of these use cases I have picked up from the Hadoop's website. And out of this one, almost all of these I have worked upon at one time or the another. So fraud detection I have worked upon in a finance company, not the click fraud one. Now, and there are many more such brands, such companies who are using big data. And this is a slide which is basically about Hadoop. The bigger the font in this slide, the total number of nodes are higher. So Yahoo has got highest total number of nodes. All right. Okay. So, all right. Now, these are the common myths about big data. Okay. Big data always means data above or in range of terabytes. If you want me to clear up any of the myths, I can clear that. Okay, that's a good point, Abhishek. Thank you. Yeah, Google is not being featured here. As I told you that this is about Hadoop. Okay, and Hadoop is essentially most of the basic three components are based on Google's products. And so yes, although Google is a big data user and probably the biggest big data user, but this slide we have is based on Hadoop's usage. So Google doesn't use Hadoop. That's the reason. Although this slide doesn't convey that part. Okay. All right. So EDW means enterprise data warehousing. All right. So is everybody able to hear me clearly? Because there are two persons who are complaining. All right. So Anpurna's question is there a minimum threshold of data size above which we can call it a big data? Not really. Even if there was a threshold, it would keep changing every day because every day new hardware comes in and new softwares are built. All right. All right. Great. Great. Yati says that Google used Dockers in volume of thousands and not Hadoop development. And I can tell you for sure that Google doesn't use Dockers also. Google has their own proprietary ones. All right. Okay. All right. So we have, okay. So everybody is able to hear me clearly. So, so Anjana can help those two persons who are having problem. Yes, Askar, the whole video and everything will be uploaded elsewhere. So, okay. So, does anybody has any questions related to these common myths? If nobody has, then I'll move on. All right. So, first one is it always means data above or in the range of terabytes. Is always so no, as we have already clarified. Then it's about social media. Answer is no, because there are all kinds of data sources which you could utilize, and social media is not the only way to have the big data. Will replace enterprise data warehousing? No, it will coexist with enterprise data warehousing. While enterprise data warehousing works with transactional data, okay, we in case of big data, because we use multitude of computers, it's difficult to provide the transactions easily, and hence most of the big data solutions will not be so transactional in nature, right? Therefore, wherever you require transactions in place, you would prefer the traditional relational systems. Otherwise, you will use big data solutions. So fourth one, of course, is not this is a new concept, will be future, is expensive. Okay, this point I like to talk. Is expensive? Answer is no, because all the softwares under big data, almost all, are open source and free. For example, Hadoop, it's absolutely free. In your organization, you can start using it. Only for if you require a company who can support it, then you might have to pay the company. Okay, the documentation, everything is available in public, and we have enough hardware, don't need it anymore. It's not about the hardware, it's about the solution. We will build it when we need it. This is the common problem which we see every day, because it has the other effect. So if you do not have the space, you do not have to build big data solutions in house, your people, your developers will not be storing the data properly. Meaning they'll be not be logging all the activities, they will not be logging all the diagnostics, and therefore you will not be gathering enough insights into the user's behavior other or at other places, and therefore you will never be in a shape to handle big data. All right. So big data is also not only about Hadoop, it's about all these new generation of systems, maybe MongoDB, Cassandra, everything, which lie, which can handle huge amount of data. All right. All right. So how is big data saving money for businesses? Okay. So there are lots of use cases for an organization. If you have built a big data platform, then you can examine your assumptions before building the product, evaluate sales and marketing strategies, retain new customers and I mean retain existing customers and attain new customers. A/B testing, as in A/B testing is when you want to display one set of interface to one user and one other set of features to another user. In those cases, we call it on a percentage basis, and we compare the results of the two, that whether a feature is performing good or not. So in A we put the usual one, in B we put the newer set of features, and we compare how is the reception. Okay. So these are A/B testing is from the medical terms a long back, where we used to test people used to test medicines on animals. So half of animals given a medicine, half of them are not, and then you test it. and then see the response. Similar way for Amazon, we were e- extremely big on A/B testing, and all the features. Even if there is a color change, we used to run that color change on a 0.5% of the total user base to check how is our change doing good, right? So based on the response of the users, we used to take call. Okay, so in our case, it was not in most of the Amazon.com's case. The decision is taken based on the data instead of a manager or a designer or anything else. Okay, and thanks to A/B testing for that. And then you have, so historical data analysis is far better than surveys. So instead of asking users that, hey, do you like blue or yellow, we show both these colors and see the reception by from the user's point of view. Okay, and big data. The second part of the question is it expensive? The answer is no. All right. Now Chandan's question is the difference between Hadoop and Mongo. So Mongo is just a smaller component, and while Hadoop is a big set of components. Okay, Mongo is just one NoSQL database, and Hadoop has got multiple. You will get this answer very quickly. Okay, and with respect to the career wise, big data matters a lot. Okay, big data matters a lot. Look at the Garner's report as well as Forbes report. When I share this presentation with you, you can go and check these reports, where both most of the tech magazines say that it's the most important thing to have as of today for an organization. Similarly, the distribution of salary tells that there is a demand and supply gap in case of Hadoop and big data technologies. Okay, so these numbers tell you that there is a huge gap between demand and supply, meaning there's a lot of demand but there's a few less supply in case of big data developers or administrators. All right, so let's talk about Hadoop now. So that's pretty much about big data. We talked about why big data, what big data, when to identify, and all the general questions. Now we are going to get a little bit more technical. All right, all right. So what is Hadoop? Hadoop was created by a person called Dog Cutting and Mike, and who were joined by Mike Caffarella. While they were doing their hobby project at Yahoo, they were as a part of personal project, they were building a nuts search engine similar to what Google does. So and that point of time they realized that it's actually difficult to store so much of data or handle so much of parallel queries using the traditional solutions. And in time the Google published his paper on the file system and compute engine. So they implemented Google's paper, and that became Hadoop. Okay, he named it after the toy elephant with which his kid was playing, and they made it open source, as in it Apache, and that is the biggest, most brilliant thing they did, because Apache license is probably the most liberal license of of a software product, and that actually is very important for any adoption of any open source product. And Hadoop is designed from bottom up to be scalable, reliable, and for distributed computing. All the components. So Hadoop is a suite of components. So it started with two things: file system and a compute engine. Uh, Now, as of now, it is an umbrella of product. Okay. And all the products that lie in Hadoop's umbrella are for distributed computing, which is scalable and reliable. All right. And Hadoop was written in Java so that it can run on any platform. Now here please note that when we say Hadoop is written in Java, it does not mean that Java is the only way to do things with Hadoop. Okay. It's just that it is written in Java so that it can run on all the machines. While you can interact with Hadoop in multiple languages. Now let's talk about something called under Hadoop. These are the various components. We'll go through these components one by one. Today we will discuss the file system. Then we'll talk about MapReduce and Yarn. And then we'll go into the details of other components. All of these components plus few more, such as uh, Zookeeper, and Zookeeper and Storm. Those two additional components will be discussed in 11 classes. All right. So, but today we'll be discussing the Hadoop file system. All right. In case as time permits, then we'll also move to the Yarn, but I do not hope so. Okay. Now we'll go little slower, but we will understand whatever we are talking about. All right. Instead of rushing into it, we will try to answer everybody's question. So, let's talk about a file system. Why did we need a newer file system? All those who are not aware about what is file system is those files and folders kind of a structure, okay, where you store your, unstructured content. Where you don't have to, uh, worry about the hardware the beneath your folder structure. Okay, all you need to worry about how to create a file, create a folder, right? You do not have to worry about cylinders and headers of the hard disk. Okay, so file system abstracts you from the complications of the hardware and gives you this beautiful interface where you can create folders and create files, and folders inside files and files inside folders. Sorry, folders inside folders and files inside folders. Okay, so that is file system. All right. Now a question to you is, say you plan to build, you are living in a community or in a apartment, and you all decide to build 100 terabyte movie store or 100 terabyte of data store where everybody can store their public data. All right. Now, how would you build such kind of system? Or if you had 100 terabyte of movies, how are you going to store those so that all your mates can watch these movies? All of you, say 15, 20 people are in an organization, they want to store lots of videos at a single place so that everybody can watch. So how would you build such kind of system? Any answer will do. Feel free to be creative as much as you can to answer this question. Connect the computers as network. Good point, Yalahanka. Karthikeyan is saying DC++. Excellent point. Have multiple computers, each with 5 TB memory storage. Meaning you mean to say 5 terabyte of storage, disk storage can be included. Okay. Tree structure. Okay. Then multiple hard disks to save each group of movies. Okay. That was Anpurna. Okay. All connected over a network. Good, Srikanth. Raghav says that a set of disks connected on the network share. Good. And set of disks connected on a network and have it connected. That is Anpurnam. We can use multiple systems as one. That is Rafikul. That's a good point. But how is my question? Yes, Venkat. Use commonly available disk. That is Pradeep. Connect through Wi-Fi. Okay. We'll store this data at multiple locations and connect them. Provide an index to retrieve them. Very good point, Abhishek. Network storage drive. Okay. Cloud storage. Sort movies based on the language or genre. All right. All right. All right. All right. So great. Great. Keep your questions coming. Keep your questions coming. Right. Raghav says that he's curious to know how Netflix does it. Good point. You build, okay, Yati says you build a master file or metadata, which kind of indexes, and tell you which movies were good once you store in network of disks. Good, 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 good. So awesome. So that was Yatish. Good, good point. Now, okay. So I think let's do one thing. Let your questions coming, and we take a break of 10 minutes quickly and come back and okay. All right. Let's come back after 10 minutes. So I'm back, guys. So John is asking, is it possible for audience to chat amongst themselves? Actually, it is generally possible if we are using GoToMeeting. But in GoToMeeting, there is a limit on number of users, and therefore, for the first session, we keep it on GoToWebinar instead of GoToMeeting. And from tomorrow onwards, you will be able to chat with audience will be able to chat with each other. Okay, from the session 2 onwards, right? Are you able to hear me, John? From tomorrow onwards, session 2 onwards, people will be able to chat amongst themselves. We'll be using GoToMeeting for this. All right. So I'm sort of back. So I'll wait till 8:43 and then we'll start. In the meantime, please feel free to answer this question. If you have to build 100 terabyte storage, or if you have to store 100 terabyte data, how would you build your solution? So please feel free to answer this. Awesome. Okay. Okay. So we have a session of 60 people. All right. All right. So most of us have already answered and have answered pretty well that we will be building something of this sort. And some of us have given an additional point that we'll have an index containing what will go in drive 1, what will go in drive 2, what alphabets will go in drive 3, and so on, right? So there will be an index which will basically map which movie is where. Good, good. So, okay, Karthikeyan and Gridhar. So basically that's what we are trying to build. S3 or Hadoop, that's what we are trying to build. Okay. Yes. All right. So yeah. So so here what we have done is we have taken 100 drives, each of 1 terabyte size, and somehow connected them either into a single computer or multiple computers, and all of these computers are connected together. Okay. So that so that all of these hard disks are available in the network, meaning each one of them is having network file system. So and all of these drives are mounted at a single computer or maybe multiple computers, so that to we get a uniform structure. So and how are they mounted? Each folder is pointing to each drive. Okay, so imagine that you had got a big folder called movies, under which there are folder 1, folder 2, folder 3, and so on for each of these 100 drives. Okay, so when you store in folder 1, it goes into drive 1, if you store in folder 2, and so on. So this is the solution we actually used to build in 2002 kind of time, few years from now, and actually lots of people are still using it. Okay, I was actually talking about somebody very from a very prestigious organization. They still use exactly this kind of architecture to store their data, right? And this is a common structure. So do you foresee any problems with this? Disk failure. Excellent, excellent, Harish. So now let me just try to patch the system. So we realized that, oh, there is a disk failure that might happen in this system. So what I done here is, let's say we bought 100 more hard drives of 1 terabyte each, and on each system I have backed up each drive with another drive. All right. Now you have got on each hard disk, or each computer, for each hard disk there is a backup on the same computer. That's how the RAIDs were built. RAIDs means a copy of one hard disk was maintained on another. All right. Network issues. Excellent. Now we solved one problem. The RAID, the standard classic RAID, solved one problem of disk failure. But what about network failures? Very good point, Harish. Any other? If the files are very big and share between drives, good, good. So if you have got a big file that's not fitting onto one hard disk, what would you do? Do you leave that space, or what would you do? Okay, okay. Keep your answers coming. I know that there are a lot of problems with this system. Split them. Okay, you are giving me solution, Karthikeyan. Okay, all right, all right. Yeah. So this system will store only small files. That is Yalahanka's answer. Yeah. More. Keep your answers coming. I know there are multiple problems with this kind of a system. In case this architecture is not clear, I can repeat it for you. If you want me to explain again, I can do that. All right. This is very important because most of our network attached storage or area network were built in this fashion. So Shrikant is saying that if possible, I'll break it into multiple fragments. Okay. So we have taken 100 hard disks, or let's say we have taken 200 hard disks, and each hard disk is backed up on the another hard disk on the same computer, and attach these hard disks into a network so as to make a folder structure. Okay. So as to make a folder structure, we have these drive 1 is stored somewhere, drive 2 is stored on another computer, and we start storing, right? So do you foresee any problems with this? First problem was raised that what if one drive fails? So we provided quickly a patch saying that we'll have two hard disk on each. Do you foresee any problem with this? Yes, searching, retrieving may take a long time. Very good point. Any other? Transfer bandwidth. Yes, because when you are retrieving data from drive 1, so only one bandwidth will get. We'll get you come to this one in detail. How do we handle the future growth? Good point. So future growth as in, say, scalable, as in tomorrow you realize that these drives are not sufficing. You add one more hard disk, or you add 20 more hard disks, or you double the capacity. Now you will have to rebalance it. Okay. You'll have to do all of that mostly manually. Main folder is the only point of access. Okay. Main folder, yes, that is another problem. So main folder where we have mounted all these hard disk, that computer will get bogged down with so many requests. Knowing where to go. Excellent, Vinay. We would know we'll have to prepare that index and keep on changing that index in order to figure out which file is where. Excellent. That's again. Okay. All right. All right. So Shravan, Annapurna, and Vinay, all three have the same point. Fallback and sync problem. Yes. Yes. Okay. Right. Right. All right. Map of the drive with the identifier of the data in the drive. Yes. Okay. Okay. Good. Good. So we have got good amount of answers, right? So the main problems with this kind of solution are these. You already have, most of you have answered all of these. Let me reiterate. So when we said we backed up our hard disk, because anytime you propose a solution, most of will jump and say, we have RAID, we have RAID, we have RAID. RAID as in RAID, redundant array of disks. Okay. So RAID basically what it does is it takes the backup of one disk into another on the same computer. It protects you on the failure of a particular disk, right? But it does not protect you from network outages. It does not protect you if a computer shuts down because of some OS corruption or some there could be hundreds of problems with a computer. CPU burns down, RAM becomes loose, or there are hundreds of reasons why a computer can shut down. Okay, so the RAID does not provide you a protection against such kind of thing. All right. So failover and backups are poor in this system, even though we had RAID 1, RAID 2, or whatever we try to do. How would you distribute the data uniformly? Okay. This point has got multiple connotations. First, how will you make sure the server 1 and server 2 are equally busy in terms of disk as well as in terms of people requesting for the data? Okay, both. So data distribution as well as load distribution is bad in this scenario. Okay. So last point is about load distribution, and third point and fourth point is about in this one is about best use of money. So first, you might be having a lot of hardware already. Some are 500 GB, some are 200 GB, some is 100 GB, some 10 GB, 5 GB, and so on. And if you try to incorporate those kind of hardware into your solution given in the previous screen, you will end up becoming really, really bad at it. You'll require a lot of intelligence for basically distributing your data. Third, there could be similarly 1 TB is not the only, I mean, is not a very cost effective solution. Okay, so why can't we use our existing hardware or lower end hardware to solve this problem? Because if you have lower end hardware, then you, instead of having 100 computers, you will have thousands of computers. Okay, now what about increasing accessibility? This is very, very important thing. So recently a new movie came onto DVDs, and you uploaded that one and informed everybody. Now everybody in your network wants to watch this new movie which you have just put in. Okay. Now what will happen? That computer on which that movie is located, everybody will try to access it, and that computer will get overloaded, and probably it will burn down. It will burn down, right? Therefore, accessibility is really, really bad in this system, right? Data security, yes. The data security is so there are two parts to data security, Rafikul. First one, when we say security, is security against illegal use, illegal access of the data. And when we say security, sometimes we talk about backup also. So which one are we talking? Security, that's a complete different issue, as in people should not be able to access. That is something which is on application level. All right. But in case of data safety, where data should not get lost, the solution doesn't work well. All right. All right. So, and that's why, because of these reasons of these kind of architectures, so security over illegal access, that is Rafiqul's point, that is anyway, that has to be defended on application layer. Okay. And that can be done using these systems also. Okay. The older systems also, they provide a reasonable amount of security. You create account, you create a Kerberos system where you give permissions to the users and give only the access to few people. All right. In this system, security can be maintained, and so is in this one. All right. So to defend against these challenges which we talked about, failover, distributing data uniformly, the cost effectiveness, and the accessibility, the distributing load uniformly, for these reasons, and also ability to scale out. Okay, ability to scale out. What does it mean? What does it mean, ability to scale out? It means that tomorrow, if you have more computers, you should be able to add them quickly and distribute the data. Similarly, in case you have to decrease capacity, you should be able to decrease it quickly. So that is some interesting ideas that has gone into the whole thought process of HDFS. So 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 whenever you are storing your data over a network, then probably HDFS is the best solution as of today. All right. While your native file system abstracts the intricacies of dealing with the hardware, dealing with the actual hard drive, HDFS abstract you from these complexities of backups and these complexities of the various indexing and distribution of data. All right. It hides all of this complexity from you. Now, how does it do all of that what it claims to do? Let us look at this diagram. Okay. So this diagram essentially has two kinds of node. Basically, just look at the lower portion of HDFS. Okay, this lower portion called HDFS cluster. Now, what it does it have? We'll talk about HDFS, then we'll talk about MapReduce engine later on. But let's just focus on building such a file system which can give you all of those points which we missed in the last slide. Okay, the whatever our system was lacking. Now you have got two kinds of nodes. First one is admin node and second one is data node. There are multiple data nodes while there is a single admin node. Some of us talked about creating indexes, right? Creating a place where we know which file is where, right? That's what is done by admin node. All right. So you can feel a little happy about yourself because because you have actually guessed that this is how you could have built it. You could have built a admin node this way. All right. So admin node essentially has this metadata about what is where. Okay. While the data node stores each file into the network. Okay. So data node is the one who is responsible for actual storage of data, while admin node is the one which takes care of noting down which data went where. Okay. There is always a single admin node at a point of time, while there are multiple data nodes, and you can keep on adding and removing data nodes. All right. Now, second point is that each of these data nodes, right? So name node is sort of a master of the system, maintains and manages the blocks which are present on data nodes. And before we jump onto data nodes, before we jump onto blocks, let me explain this. So data nodes store the data. And in what format is this data? This data is in the format of blocks of fixed size of 128 MB. So whenever you are trying to store a file, it is sliced into blocks of 128 MB and stored on the data nodes. All right. So which means that if you have 1 GB file, how many blocks are there? Quickly. 8. Excellent. So name node, admin node, master node, these three words we will be using interchangeably. Okay. So for a 1 GB file, it will create 8 pieces, and it might store all those 8 pieces on a single data node or another one. All right. Now, now now this next point is that each of these blocks are replicated. What does it mean by replicated? It will have copies. Each block will have multiple copies. By default, each block will have 3 copies, and you can change it per file basis as well as per for the whole system. All right. So let's assume for time being the replication factor is 3, which means each block will have 3 copies of itself. Why? For the backup. And each of these blocks are stored. All these 3 copies are always stored on different computers. Why? Because if you store all these 3 blocks on the same computer, that means that means it is useless, completely useless, because as we talked about RAID, in case the network goes down, if both the copies are on the same machine, it doesn't make any sense. So if your replication factor is 3, you need to necessarily have 3 data nodes minimum. Okay. If you have lower than that, the HDFS will give you error. Okay. So each file is splitted into blocks of 128 MB, and these blocks are stored on data nodes. And each of these blocks are duplicated and have been copied onto other nodes. Now, you can very well guess that in case one particular data node goes down, you will have the loss of blocks, right? Which means, but even though you lost a lot of blocks, you will have copies of each of the blocks somewhere in the network, right? And the moment name node comes to know that we have lost one data node, it will inform other data nodes containing those blocks to start copying and replicating it to another machines, so that the blocks replication again becomes 3. Okay. Because of the loss of one data node, some of the blocks will be lost. Their replication factor would be coming down to 2 from 3. And in this moment of time, uh, name node informs the other data nodes containing those blocks to start replicating onto some other nodes. Right. Now, so we talked about few things. Admin node stores metadata, data nodes store actual data, and the actual data in the form of blocks of 128 MB. We slice each file into 128 MB. In case the file is smaller than the 128 MB, the block will be smaller than 128 MB. All right. So now we can easily guess that even if our hard disk is as small as 128 MB, as small as say 200 MB, it will still make sense to put that hard disk into this network, right? Even if we are storing DVDs or we are storing Blu-rays of 80 GB size each, still we are able to utilize the low end hardware because each file is going to be splitted into smaller blocks, right? So we talked about master node, slave node. We talked about metadata and actual files. We talked about each file is broken into blocks. We talked about each block is replicated onto the network multiple times. All right. So that if there is a loss, it rebalances. Third is in case a data node is added. If we add one more data node, then the some of the data from existing data node moves to the fresh one. All right, moves to fresh data node. Some of the data. Now this distribution and balancing keeps happening all the time. This distribution and balancing keeps happening all the time, right? Now the other important aspect which we talked about in previous slide, the problems with the older system, was accessibility. How does HDFS address accessibility? First, since each block is stored on multiple computers, okay, therefore whenever you are watching a movie, some when you are on the first 5 minutes, you will be watching it from first data node. When you are watching the second 5 minutes, you will be watching from another place, and so on. That means the load is beautifully distributed onto all of your nodes. All right, does it make sense to you? Now, other thing is that the impression admin node and data node seems to give you is whenever we need data, we would go through admin node. The answer is no, right? Because if all the data is being handed over to you by admin node, if admin node is the one who gives you the data by asking data node, right? If admin tries to abstract you from data nodes, that means admin node will become the bottleneck and will crash very quickly, right? Instead of that, every time you have to read a file, you go to admin node, you go to admin node and say that, hey, I want to I want to read this particular file, and admin node gives you the data nodes and the block numbers stored on those data node, and tells you that, hey, go to these data nodes, don't bother me with the reading of the data. You do the reading of the data from each of the data nodes. Okay, similarly for the writing, when you go to name node, hey, I want to write this file, admin node says, listen, you write your data by yourself onto these data nodes, and these are the blocks you need to create out of your files. All right, so that so that you, as in the driver you are using, the command line you are using, will be redirected to data nodes every time you talk about reading or writing actual data. And name node or admin node helps you doing that. Okay, every time you want to read or write the data, you go to name node. Name node gives you the information about where is the block, and then you can go to that particular data. Okay, so even if you have to skip to the end of a movie, you don't have you can just ask name node that, hey, give me the data from this byte to this byte. Okay, and now based on that, it will direct you to the correct data node containing that particular block, containing those bytes. All right, now the next question that comes in is, still name node is singular, And also, when you are done with when you start writing the data, you first inform the name node, hey, I want to write this data. Admin node says, hey, I have made the entry that you are planning to write this data. Once you are done, please inform me and go to these nodes and write your data there. And once you are done, come back to me so that I can mark for sure that you have written this file. I can update my metadata with this newer file information, right? In case this client does not return after writing the data or before writing the data, does not inform name node assumes those changes are not done, and there is a timeout on that. Okay, and which means that the changes will get lost, right? So any changes which are not done without informing admin node, confirming to the admin node, those changes will get lost. All right, because admin node is the one which knows which file, which block is where, who is doing the whole planning of the resources. That is the admin node. All right. Now, next question comes in. What if my admin node fails? What would you do in case your admin node fails? In those circumstances, you will always have something called a backup admin node, which will have a copy of the same metadata which is admin node is storing, and copy of the same data which admin node is storing, so that you can bring it back to the life with the same metadata. Okay, now there could be multiple similar questions. There I started writing data to the data node. It was taking time, and in the meantime my admin node got shut down. Okay, so the changes which I have done are lost, or what should I do? Will the data get corrupted? The answer is your changes will get lost by the time the newer name node comes in with the proper metadata. Okay, you'll have to write the data again. All right. All right. So there are lots of questions. Let me answer you. Okay. So a lot of people broke my. I mean, my voice broke, and where did I? Okay. Okay. I should have kept an eye on the questions. All right. Is everybody able to hear me now? Hello. Oh, okay. Not clear. Are you able to hear me now? No. Okay, okay. So I don't know from where my voice broke. If somebody can tell me, I can um, repeat from that point onwards. So let me answer the questions. Is admin node and data node rights are transferable? Does data node broadcast messages in case of new addition of item? Okay, okay. Does data node broadcast message in case a new addition of item in it? Yes. So the way name node and data node generally communicate is by the way of pings, by the way of heartbeat. They can name node can query the data node and keep itself updated. Similarly, data node can also inform name node. Okay. And rights are transferable. That's a very different, difficult question to answer. Let me explain to this again. So, before thinking of anything, Let me explain what exactly does it mean by data node. Is it a hardware? Is it a software? What is it? So data node is a process which runs on a particular port. Okay, and same is the case with admin node or name node. All right. So all of these are basically Java processes which are running on your machine. Each of them is a JVM. All right. Now you can have all of them on a same machine, although it will work, but it doesn't make any sense. In the virtual machine, the people download it. All of that is there in a single machine. Okay. Now, is the duplicate copy true for admin node also? No. So admin node is basically contains only the metadata. A single copy is retained of the metadata so that the data is consistent. The file system is consistent. Okay. Now the admin node is a the most of the metadata in admin node is in the RAM, and the copy of that metadata is in the disk. Okay, the copy of the metadata is in the disk, so that in case the RAM machine shuts down, you do not lose the metadata, right? Now if the metadata if the so admin node is the one computer where you might require a higher RAM, you might require a bigger size of RAM, while data node you don't require a higher size of RAM. Okay. What is backup for the name node? Name node, we have something called backup name node, or we can have something called secondary name node. Both are similar in nature. They keep a copy of the metadata, and the metadata is generally reasonably updated. It's just the secondary name node takes more time to come back to life than backup name node. Okay? Okay. So Sri Kumar is saying that isn't the duplication consume more data? Yes, it does. It does consume 3 times of space, but hard disk individually is cheaper. But building a reliable storage is a difficult thing. Therefore, it is okay to sacrifice 3 hard disks or 2 hard disks based on your need. Okay. So the replication factor by default is 3, as I said. In case you are storing a data which is of less importance, you can keep 2 copies. If your data is higher important, very highly important, then you keep its copies at 10. Okay. So if there is a new movie that came into your network, you can keep its replication factor to maybe 20, so that there are 20 copies on your network. But as time passes and people stop watching it, you can basically change the replication factor back to 3 or back to 2, so that it doesn't consume too much of space. So space consumption is heavily tunable, but as a general practice, it's okay to sacrifice space in return of the reliability and so many features. All right, that was Sri Kumar's question. I hope I'm able to answer your question. Can we have admin node a cluster of computers? That's a very, very difficult thing to build, and people are trying to build it using Zookeeper. But name node singular is good enough as of today. For a small file where complete video could reside on one system, how will accessibility be addressed? Okay. Okay. So that is Harish. Thank you, Harish. So if you have a small file where you store that, it's, let's say it's 100 MB file. Now this file is on a single node, it's a single block, and it has 3 replicas. So accessibility cannot by default be great for this, because all of the people are asking for the same file all the time, right? In these cases, as I told you, you can increase the replica size to 10 in the beginning, and then you can go ahead. All right. All right. Okay. Yatish's question is that name node will have strained alone or a cold backup. Basically, it is a cold backup. What is difference between cold backup and hot backup? Hot backup swaps with your system quickly by itself, while cold backup is something you might have to do it manually. So, backup name node or secondary name node are generally cold backup. Okay. All right. Now, so does no name node broadcast its failure of its own to the user to prevent further data loss? So the way it happens is that when the user is trying to access the name node, it will anyway give the error. While various kinds of errors are notified to the admins continuously. Okay, that was Ashirvad's question. Does RAM required for admin node depend on number of data nodes? So the RAM required by admin node depend on how much data are you using and what is your block size. So block size for the whole system can be same, but the moment admin node realizes that your block size is smaller and you have got too many data nodes and too much of data to be stored, it starts increasing the block size. It starts increasing the block size because if you have more number bigger blocks, then you have lesser number of blocks, which means lesser amount of metadata. Okay, so that is how admin node cleverly tries to handle the situation of having a lower memory. So what is the difference between secondary name node and backup name node? The differences between secondary name node and backup name node is not much. It is just that the time taken to bring back to life in a backup name node is easier because it contains the whole metadata as is. A complete copy of the admin node in case of backup node is there. While in case of secondary name node, you will have to prepare the metadata from one which is committed and then journal. So therefore, secondary name node bringing back the secondary name node to life is a difficult situation. Okay. All right. I see this setup similar to enterprise NAS storage. Data is spread across controllers. They act like a name node. Yeah. So Srinivas, so the difference between network attached storage and this one is very different. Network storage attached is there is a controller which keeps taking care of the network drives and all. But there the file is not splitted into chunks. File is not splitted and there is no auto balancing. Okay. How replication factor can be controlled? Is it at data node level? So replication factor is first based on each file and second it's based on the default value for the whole name node. Okay. So each name node will have there will be one name node, right? So this name node will be configured from you can configure it to have the default replication factor and you can change replication factor on per file basis also. Okay, I may be a bit factually wrong here. I'm reading Abhishek's question. The block diagram has similarity to Unix file system. how can we how we can point out more difference. Okay, so most of these systems are master slaves, and master slaves is a standard way lots of machines work. Okay, so that's why you might think that this is a similar diagram, but the devil is in the details. Devil is in the each feature, such as balancing and block sizes and all of that. Is there an option to auto scale number of replicas? Okay, I want to understand what does it mean by auto scale. As in, if the demand of a file increases, then you change the number of replicas automatically. Is that what you mean, Harish? Okay, so right now, no, but you can build your own if you have a customer facing application which where you are tracking what is the what for which file a request is coming too frequently, and based on number of requests you see, you start increasing the replica. Okay, you can just remotely set the replication factor to for those files. All right, very good question. This concept is similar to mirrors we have in Linux distros, yes, based on increasing requests. Okay, so I have answered that question already. Is replica label configurable at data node level? I think I have answered Cassie Reddy that question. Okay, yes, it is answered. Is it possible to configure replica size based on size of a file at runtime? Is it possible to configure replica size based on the size? No, actually, replica size. Okay, you mean to say, Shrikant, that if the file is bigger then we have big block size? The answer is no. Okay, the answer is no. Okay, so the block size is per file basis. Sorry, per system basis, not per file basis or per data node basis. All right, thank you, Rafikul, for answering hot backup and cold backup. All right, is there a difference or are they same? So I think I've answered Anpurna your question regarding backup name node and ne- will the read operation work when admin node fails? Okay. So Srinivas's question is, say you started reading the data from data node, right? And at the same time admin node failed. So will you be able to read the data from data node? The answer is yes. Okay. But if you go back to admin node, if next user comes in and tries to read the data, it will not get the metadata and it would not know where is your data node, right? Ashirvad's question is, does change in reflection factor auto sizes data nodes? Example, if I reduce, yes, yes. Okay, so your example makes it clear. So his question is, does change in replication factor changes the storage space available? Yes. If you have, as you have said, that if you reduce your replication size from 3 to 2, the space stored would also become more space will be available to you. Okay. So for example, on our servers, we had one file of 50 GB. Now, if when we had three replicas, so the overall consumption of the storage were reduced by three times. Okay, which means 150 GB was consumed. So 50 into 3, 150 was consumed. But when we change the replica back to 1, then this file only consumed 50 GB of our total space. All right. Is it possible to configure replica size? Shrikant, I have answered no. Is it possible to configure replica size based on size of a file at runtime? If the size is this, we have 10 copies. If the size is 150, yeah, that you can do, right? As I was telling you. So you can write your program because your program or your command line will be talking to file system. So you can write your program if the file size is greater than this, while creating the file, mark its replica factor this much. If the size is this much, then mark this. So it's completely flexible and it may gives you option. Very good question. Thank you. All right. Okay. So Yalanka's question is, if we change the block size, what happens to the previous file with the smaller block size? So first, it's actually pretty difficult to change the block size, right? Because block size is generally based on the compilation time. Okay, you can't really change it. Second, if you say recompile your Hadoop with a new one, then it will do the rebalancing. It will also try to break the blocks into further. All right. Older blocks also it will take into account. Will all block sizes be the same? All right. Yes, all block sizes will be of the same size. All right. Now, irrespective of where we store the data, on which data node, which file are we trying to store, the block sizes will be same. Okay. Now, you said for reducing the metadata, the name node changes the block size if data node increases. Does it impact the historical stored data? Yes. So, yes, it does impact the historical stored data. And also, I need to see what is the current strategy. The last time I checked, they were changing the older one also. Let me also go into the details of that one. Okay, okay. So, Sri Satya, you said that is what I have been doing. Could you just tell me which one you are referring? I didn't see your answer earlier. Does the data node need to have JVM installed? Thank you, John. Yes. Okay. Each data node is basically a JVM running. It's a Java process. So replication factor is specific to the file. Then Y- Yeah. So Apurv, yes. So replica factor you can change per file. If you do not specify replication factor, then the default one is taken. Do you have to size the disk based on number of data nodes? Okay. You have to have greater spare space on each disk. Okay. Do you have to size the disk based on number of data nodes? No, because each data node will have its own disk. You have to have greater space on each disk for the cluster for larger data nodes, yes, to support for larger failure rates. Also, will there be spare data nodes? No, actually, there will be no such thing called spare data nodes. As the blocks come in, the blocks will be written to, I mean, a block could be written to any data node. Okay, so which means that when the all of the data nodes will be utilized. Okay, how does allocation of space on data node work when replication size is reduced? Does data node service provide the remaining space to the machine? Okay, so the answer is yes. So when we create a data node on a particular machine, let's say you have a machine which has 50 GB of space, total 50 GB of space, okay, out of which some X amount is available. Okay, so by default, 80% of your total disk is given. uh, I mean, 80% at most can be given to the HDFS, to the data node. But in the meantime, it does not mean that the whole data node will consume the space and leave, it will not leave anything for that machine. Okay, so it will have, so let's say there is a data node, it is right now storing only 1 GB on a machine which is having 50 GB of space. Okay, so out of 50 GB, 80% is 40 GB. So at most up to 40 GB, this data node will consume, rest 10 GB will be available for for the local system. All right, but when your data node is only consuming 1 GB, that means your local file system will show the disk available as 49 GB instead of 10 GB. Does it make sense, John? So good question, Ashirvad. Who does the cleaning activity or auto sizing of data node, and how frequent that could be? Okay, so most of the activities are initiated by name node, but name node cleverly delegates most of the work back to the data node. For example, let's say new node is added, right, into the network, and you told admin node, hey, we have got one more data node now. Now what will admin node do is it will figure out which data need to be transferred to the new node. All right, and instead of it itself transferring the data, it will inform the other data nodes to start transferring to the newer node. Okay, so therefore, there is a direct communication between data node 1 and data node n, which is newly added. So it is faster, and it is not blocking admin node from, uh, it is not keeping the admin node busy. So the cleaning up, balancing, auto sizing, all of this is done by admin node in conjunction with the data nodes. All right, it utilizes as much as it can. Okay, how is the number of data nodes decided? So data nodes is completely up to you. How many machine do you have? You can put them and make them data node. It's about your expansion plan, how much you want to spend money on this, and also how much data do you want to store. All right. So if you have to store 500 GB data, if you have to store 500 GB data, then you need to have at least 1500 GB of storage. And now if each of your data node is containing 100 GB hard disk, that means 15 data node minimum will be required. Actually, more than that, you will have to take into consideration 80% of the disk size, right? So that way you will have to close to 16 or 17 you will have to consider. Okay. And at least minimum of the data node you require is equal to the maximum replica factor. If you have a file having the replication factor of 10, you should have at least 10 data nodes. All right. So that is how you decide upon the data nodes. That's a good question. Uh, all right. Thank you, Annapurna. And Ankush's next question is that if data are stored in different nodes, will admin node return all node detail if I need complete file? Yes. Okay. It will tell you that this block in this node, this block is on this node, this block in this node, and that all the blocks that are there, it will return you. Okay. Okay. So Yatish, your question, could you write me an email? I would, because this involves all the advanced concepts also, which I would not like to answer now. Maybe in the second session I can answer. All right. Or maybe once I discuss the task tracker and job trackers, because that will disturb other people. So Cassie Reddy's question is, if we add a new node, how does HDFS determine which blocks to move to that node? Okay. Does it a blocking operation, that is, if some new read write request comes to a file for which block is getting moved to the new data node, is this operation success or failure? So if the data is getting moved, then 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 it's a blocking operation. Okay, it's a blocking operation. If the data is getting moved to another machine, it will block all the read writes to that data from the user point of view. Okay. And if that blocking times out, then it's an error for the user. Does it make sense? So if we add a new node, how does HDFS determines which blocks to move to that new node? And does it a blocking operation, that is, if some node read write request comes to a file for which block is getting moved to the new node, is this operation successful? The answer is, first, data first get copied and then can is deleted from this node, right? Till the point the data is deleted from this node, it can serve the read requests. Okay. And later point of time, when you are about to delete this data, at that point of time all the read requests are blocked. Okay. So it does it really neat manner, it does it in really neat manner. All right. And in that case, does the mapper run on all blocks in that file or entire HDFS in the... So we haven't discussed about mappers, Yatish. Just give me maybe once we talk about MapReduce in the next session, if you can hold on till then, or drop me an email. And we have just launched a forum. I'll try to answer your question over there. Okay. Even if you are not there in the second session, I will take up your question. All right. It's a good question, really interesting question. I would love to answer that. Will there be storage consolidation done via deduplication of data blocks to retrieve. Of course, yes. So that was Srinivas's question. He meant to say that in case you decrease replication factor or you do some other operation, so do we reclaim the space automatically? Answer is yes. And I have just done it yesterday only. Okay. Because one of the project finished for one person, so we just decrease his replication factor from 3 to 2 so that we could retrieve the space. Right? And it was automatically done. How different is service-oriented architecture from this solution? So service-oriented architecture is just one philosophy which says that instead of using another team's library, you use it over the network like a service. That's what service-oriented architecture says. Okay. While this one is a whole new paradigm of the computation. Who will copy new data to the data node? So data node communicates in between themselves for copying the data. Name node just informs them. All right. So I'm hoping that HDFS is clear to you, all of you. All right. So we will discuss about the yarn and other components in the rest of the sessions. Today we are going to basically cover some more questions. Okay, let me answer some more question. Okay, who will copy? Okay, so Gridhar, was I able to answer your question? Continue to my question. Let me find out Ankush's question. Okay, okay. If the data are stored in different nodes, will admin node return all the nodes detail if I need complete file? Yes. What if node details of data got changed between reading? No. So first, if there is a read request going on, then I mean this is standard locking mechanisms. So it doesn't let you change the files. So change the data as in place. It basically append only operations, most of them. So that in case you have to delete a file, you'll create a file and then you drop the previous one. As well as when you have to alter something, it's a very difficult operation in case of HDFS. It basically rewrites the whole block. Okay, so that way this is a standard, what do you call, the I mean the read write locks, if you have read in any system. So basically, whenever users are reading it and somebody tries to modify it, they will not be allowed to modify it right away. Instead, they'll be creating a fresh blocks, and then later point of time when readers have exited from the file, then it will, those writes will come into picture. Okay, all right. Now, okay. So, Gridhar, your question is who will copy new data? So I was saying that whenever you copy a new data, it's a responsibility of data nodes as well, other than the name node, to make a note of it. Okay. Actually, I'm not able to figure out the question. I want answer on very first copy of data which we want to copy on the first data node. Okay. Could you just please reframe it? It'll be great. It'll be easier for me. All right. We have some time, so nothing to worry. You just write down your question comfortably. All right. Now, or in case you think it will take some time, just feel free to drop me an email. No worries. Right? Now, we talked about Hadoop distributed file system, and then there is a compute engine. So we had data across the file system, each containing one block, and it's distributed in the network. Now, compute engine helps you do the computation on each data node instead of a single node. Okay. When you have to process, let's say you have to do some operation on the top of file, say the classic case of word count itself. Now there could be two things. One is you read the file from hdfs, count the words, read the file from each data node 1, data node 2, data node 3, and so on. And after reading the data you do the processing, and then you give the results, right? Now here what happened is there are two very big problems that would happen. First, you are reading the data, which means your bandwidth is the bottleneck. Remember the fourth pillar we talked about, network. So since you are transferring a humongous amount of data, a 1 terabyte of data transfer over network might take more than 6 7 hours, okay, or maybe more. So first, it'll take too much time of data transfer. Second, you are doing counting on one single machine or sorting the data on a single machine, which if you could distribute to all the nodes on which this file system itself is running, it would be just wonderful, because you distributed the effort, as well as you distributed the computation, as well as you distributed the file reads and writes. So your processing will become more than n times faster. If you have n number of nodes, it will not become n times but far more than n. Okay, so that is the compute engine. Compute engine distributes your logic onto multiple nodes. Now how do we build such a logic which can be distributed? That is how MapReduce defines that paradigm. Now, there is similar to MapReduce, there is Spark, which also helps you build a logic which can be distributed onto multiple computers without you putting all the efforts in figuring out how to actually distribute your logic. Okay, so Spark helps you. Spark provides you a programming language. MapReduce provides you a paradigm, and so on. Now, all of them use the HDFS. Okay, so that is about compute engine. We will cover compute engine in details in the next session. Okay, now Gridhar's question is, suppose we want to copy new data into a data node later, we will replicate it. So suppose we want to copy new data into a data node later, yes, we will replicate it. So who will do it? Okay, okay. So say you are adding more files into a data node, all right? You are adding more files. So your request will first go to the name node. Name node will give you that, hey, go to this data node and put it. Now, when the replication starts, okay, replication starts between the nodes. Okay, you do first copy of your data is written onto one node, then rest of the data replication happens between the data nodes itself. All right, all right. Yes, Ashirwad, you are right. the whole system looks like sometimes like torrent, because you have distributed the transfer, you have distributed, converted a big file into blocks. So actually the system is fairly inspired by torrents. Okay, John's point is that I said MapReduce as paradigm and Spark is a language, but aren't both architecture? Yes, actually. Yeah. So Spark provides you so many constructs to qualify as a separate language, just like Pig. But if you look at it, Spark basically you write your code in an existing language such as Scala or Java. But since there are so many functions, it provides you extra that it qualifies for saying that it's in itself is a library of huge functions, or can be a good candidate for a separate language. You're right, John. Now, so both are effectively, yes, paradigm and an architecture. All right. All right. Now, so that's about the compute engine. We'll go into the details of converting any existing problem into compute MapReduce, as well as we go into the details of Spark. How do we utilize Spark and why is it better than MapReduce? Now, other than that, there is something called HBase, which is basically a data store for structured data. It stores its files, its data into the HDFS itself, but provides you a sort of a tabular system where you know about your data, that this is my first field, this is my second field, this is my third field, and so on. And your data is a billion rows by million columns. In those cases, we use HBase. If your data is in tabular format, we know what is where in those cases. If your data is completely unstructured, like physical one, then you simply store in HDFS and be happy with it. Now, so HBase is NoSQL databases. NoSQL is a new generation of databases such as MongoDB, Cassandra, and CouchDB and so on. They all have this. They all are distributed databases. Okay, and since when they tried to provide distributedness to the database, most of them, I mean, all of them could not give transactional abilities of databases, and that's when they started calling themselves NoSQL or NewSQL and so on. All right. So HBase is one. Then we have Hive. So for doing the computation distributedly, either you could choose MapReduce or Spark, but writing code every time is not possible, right? Therefore, Hive does a really brilliant job. It provides you SQL query. It provides you a beautiful SQL query interface where you can write all your logic. If you are a DBA, you have a good command at SQL. So 99% of your work will be finished using Hive. Okay, all your logic, whatever you write in Hive, will get distributed, automatically converted into MapReduces, and will run on the compute engine, and you will get the results. Right? So that is Hive. Hive makes it possible to even query the external databases and combine the data with your data stored in Hadoop. Okay. Then we have something called Pig Latin. Pig Latin is similar to our SQL. This looks like more or less like SQL, but is a very simplified and very nice derivation of SQL. Okay, it's very easy to compose your whole plan instead of trying to merge all the queries into one to get the results. Pig Latin is basically a modified new generation of language which is inspired by SQLs, but makes it possible for you to churn the data in distributed fashion. Okay, it is specifically designed for systems which want to churn the data in distributed fashion. It's very efficient as compared to Hive. Third one is Mahout. Mahout is basically a library of functions which contains various kinds of magical functions such as learning algorithms. You keep on feed using one or more to do the clustering, to do the categorization. All of these functions are available, pre-prepared for you. You do not have to write a single line of code to do most of the work. For example, writing a recommendation engine, if you are building recommendation on your product, which might take you couple of days, just a couple of days to finish everything. Okay. And for actually generating recommendation, all you need to do is call Mahat with proper input and input data, and it will give you perfect output. So you don't have to write any code to use Mahat. All right. Now, there is something called Flume and Scoop, which Flume makes you import the data from unstructured sources such as file system, such as Twitter, social media, and lots of other data sources. Scoop makes it possible for you to import and export data to and from a relational database. Now, as you can see, when you are building a big project, or even a small project, it will have many steps. First, use Flume, convert it into structured, clean it up using Pig, or churn it using Hive, and maybe you might have to put some data into HBase, and then or you will might have to run MapReduce, and later point of time you might have to run Mahout on some piece of data to build the recommendation. Now, in a project there could be 100 such tasks. Copy this file from here to there, do this, do that. Now, to do all of this in a chain, sequentially, in a neat dependable form, such as your makefile does. Makefile executes various things. Similar is Maven does a lot of things. Similar is Ant in Java does a lot of things for you. Similarly, in case of Hadoop, you have Uzi is a workflow in which you can chain all of these things together to finish your work, right? Copy this file from here, import this data, then run MapReduce, then do the Hive, then run my Mahat algorithm. All of this can be changed together using a workflow. What is the difference between Hive and Pig? That is Manish's question. Pig is a newer language. It's a cleaner and simpler version, I say it. And it lets you churn the data which is not highly structured. It can let you churn the data which is in semi-structured format. Okay, it is not too finicky if it doesn't know the data type. Say for example, you can churn a comma separated file using Pig very easily, while the same thing is not possible using Hive. First, in Hive, you will have to create columns, then you import the data, you define that this column is number, this column is this. That kind of thing you don't need to do in case of Pig. Second, Hive is basically standard SQL. So the language was not suitable for parallel processing. Therefore, Pig was invented for doing the tweaks for parallel processing. Okay. There's a huge constructs difference. When you go into the details, you'll see that. Okay. So HBase is only a database engine or a file system? No, HBase is only a database engine. It stores its files on HDFS. Okay. All right. Now, so this is the whole system, and so you can go to Ambari. You should actually explore these URLs. All the details about connecting to the cluster is available in session 1 instructions document. Go to log into learning management system, go to session 1. There there you will see your course listed. In my case, there would be so many courses. So in your case, you will see only this one. Okay. Under this, you will see the presentation, and older recording session is there, and installation instructions are there. Go through the installation instructions, and after that, make sure that you go through Ambari console. I'll also go through it tomorrow. Okay. And also go through our Hue. Hue makes it possible for you to explore all these systems. Okay. Let me just open Hue. All right. So Hue makes it possible for you to write big queries here itself. And these are all cloud part of the cloud labs. Okay. You have got pig where you can write your queries. Similarly, you can see the file system. This is if you guys are worrying that this HDFS is quite complicated, it is not. It's like the classic file system. It has hidden all the complications it does to make sure data is safe, and it provides you a beautiful file system, as you can see. So all the students, please create your own folder before fiddling it. In the meantime, I'll be sending you your personal login also. Use the student login, because that is how you learn looking at other work, other people's work. So everybody is having their own folder over here. Okay. All right. So this is our file system. You can see it's so clean. I mean, though that whole thing look like so complicated, data node, name node, and all of that, it is it at the end of the day it provides you a beautiful interface, just like any other file system. All right. Now you can go through that, and all the instructions are available. Also make sure that you finish the quiz. Okay. In case there are some questions which are not you are not able to answer right away, just wait for the second session for them and then reattempt those questions. But make sure that whatever questions you can attempt it now. Okay. All right. Now also, we have now recently launched our forum. Okay, we are working on putting all your questions over there. In the meantime, you start asking your questions so that we can comfortably answer in detail each of your questions. Okay, so this is our forum. Please feel free to ask the question there. Is Go to knowbigdata.com and then go to forum, and then please ask the question. I would be devoting all my time into answering your question on the forums and via email. Okay, even if you are sending me an email, I'll be putting that. If it's not very personal, I'll put that on forum and answer it there. Okay, so please feel free to use our forum. Okay, in few days time we'll be adding more and more questions here, and I'll guarantee that we'll answer your each questions. All right. Okay, is there any data loss when we use Flume and Scoop? No. That was Apur's question. HBase is the only. Okay, so great. With that, I have answered the other question. Okay, I'm sure you guys enjoyed the session. Feel free to drop me an email, and feel free to give us the feedback, and ask questions on our forum. All right. And those who want to go for further session, you can go for further session from tomorrow. Okay. Tomorrow, the session from tomorrow onwards is for the people who have enrolled for classes. To enroll for classes, you can go to the website itself and click on Big Data and Hadoop, and then you can do enroll. All right, can enroll now. All right, so you can go ahead, and tomorrow's class will be at the same time as today's, and you can join me tomorrow onwards. All right. Thank you, Anpurna. Thank you, Amitabh. It was a great session. I got a great response. Excellent set of questions. Thank you, Sanjay. And Yatish, please write down that question. I'll have little difficult time to find that question. Just drop me an email or drop that question on the forum. I'll answer it there so that others can also see that. If you can do that for me, please. Okay. That was a very good question, by the way. Okay. Thank you, Abhishek. It was a great to have you in session, and we'll see you tomorrow again. Yes, we have batches in 2000 January also. We'll put those information very soon. Okay. Thank you, Srikanth. All right. So, any other questions you have? Okay. Okay. Great. Thank you, Srikanth. See you, Amitabh. And thank you, Arun. I had a great session today. Thank you, Shravan. I'm happy that you found it very informative. So, Sri Kumar, all our sessions are only webinar. Okay, because these sessions are across the globe. And we found that in our physical sessions, which we did initially as a pilot, we realized that the learning wasn't good enough. We compared the results and we found that people did not learn much in physical sessions. And I do not know why is that. All I know is that the performance wasn't great. Our online students who attended the same session by myself online performed 3 times better than the physical classes one. Thank you, Sri Satya. Okay, I'm great that you found wonderful. I also enjoyed the questions thoroughly. Thank you, Sridhar. Thank you, Sankar. Thank you, Ashirwad. It's a good start for you. Yeah. All right. All right. So that's pretty much. We'll upload this video onto the learning management system as well as we'll send you an email. Those who have not enrolled yet, we'll send you maybe tomorrow or maybe in couple of hours. Depends on how much time it takes for uploading. Thank you, Suryasiri. It was great to have you in session. Okay. Thank you, Apur. Thank you, Sri Kumar. Thank you, Rafikul. I'm happy that you found it very informative. Thank you, Bharat. You learned basics. I'm extremely happy. Okay. So yes. So I'm happy that whatever objective you had in mind, you learned it. I'm pretty happy. Thank you, Ravali. You found it informative. Feel free to get in touch with us and see you tomorrow then. Bye bye. Have a great day. All right. Thank you guys. Have a good day and stay in touch. Come to our forum, ask the questions there, and I'll answer all the questions. I as well as the all our student will answer the questions, and that'll be great. All right. So have a good day. Yes, all the PPTs will be shared with you. Nothing to worry. It is already there, Harish, in your learning management system. Go to the learning management system, my class courses, on the top right, and you can see this. You can see the presentation already there. All right. Okay. If you want to keep a copy, you can keep a copy because we keep on making the change to a presentation and it reflects on all the courses. Okay. All right. So please finish your quiz. And those who have not yet enrolled, let us know if you want to enroll because there are only few seats left. Hardly 3 seats are left actually. So if you want to sign up, let us know. Okay. All right. So somebody was asking about few questions about big data in the beginning. All right. All right. So feel free to get in touch with me, whatever questions you have. I would be more than happy to answer your questions. And stay connected. Thank you very much. Have a great day. Thank you, Abhishek. Thank you, Abhishek Parwal. Thank you, Ankush. Thank you, Anpurna. All right. So I'll hang up now. If you have any questions, drop me an email at Sandeep at No Big Data or ask the question in the forum. I would love to answer your question. You can go to our forum, go to the website, and then click on the forum. All right. Have a great day. Look forward to see you in the sessions. Bye bye. I would be disconnecting now. Bye bye. Have a great day. Bye bye.